Thank you for coming in today. First of all, I would like to acknowledge the traditional owners of the lands in which we're variously meeting right across the country today. I'm sure we have people from way beyond Victoria and lots of places, and pay my respects to elders past and present, and to any Aboriginal people who are with us today, or Torres Strait Islanders who are with us today. Welcome. Great to have everybody with us today. It's fantastic the way that the ARI Seminar audience has been growing, and we're getting all kinds of people jumping in and joining these seminars. It's fabulous to have you all with us and to continue the conversation, not just in the seminars. Please put your questions into the question chat there. We'll get to the ones that we can at the end. And yeah, as I said, look out for the recording afterwards on the ARI website. So today I want to welcome David Nipperess coming to us today to share the Biodiversity Indicator Program from New South Wales. This is something of particular interest to us, of course, because we have something pretty similar in Victoria. So we're always keen to hear about what's happening in other states dealing with similar challenges. And we really welcome you, David, for coming to share your story with us today. So over to you. Thanks so much.
Aha, now it's my turn. Excellent. Sorry, I jumped the gun there before. Yes, I'm David Nipperess. I'm a senior scientist with the Department of Planning, Industry and Environment in New South Wales, and today I'm going to talk about the Biodiversity Indicator Program. We'll start with a bit of legislation. So the Biodiversity Conservation Act of 2016, one of the clauses under that says that the Environment Agency head is to establish programs for the collection, monitoring and assessment of information on biodiversity. So this came out of when this legislation was being put together. There was an advisory group, and so the requirement to actually monitor what is actually going on was built into the legislation as part of that. And so getting into the slightly more into the regulatory details, if you look at the regulation that comes with the Act, then essentially it's a little bit more specific by saying that the programs are to monitor status and trend in biodiversity. It also says biodiversity and ecological integrity, so we tend to treat those as overlapping but slightly separate things. That we are to develop a method that identifies the key biodiversity indicators, and that the agency head is to publish from time to time, which is nice and specific, on a website maintained a Outlook report. So what I'm talking about today is that Outlook report, so what we're calling the first assessment. So our first crack at it, and I will speak a little bit about where we're moving from beyond that, but we will be publishing from time to time. Moving forward. Another key point to make that is stipulated under the regulation is that Outlook report and the method underlying it are subject to peer review. We've had probably a very high level of peer review on the first assessment, and we'll scale that back a little bit on the second assessment, but essentially there will always be a level of peer review to our products, and that's external peer review too. So the method. So because this is where we started, and we started with a collaboration. At the time it was the Office of Environment and Heritage, but now Planning, Industry and Environment, worked with CSIRO, the Australian Museum and Macquarie University to develop this method. And I should just say that my journey with this program was as an academic at Macquarie University. So at that time I did not work for Planning, Industry and Environment. I work for Macquarie University, and I've transitioned across, but the whole time I've been involved with the indicator program, so it's been an interesting journey for me. Some of the key stipulations obviously is that it's status and trend, and this method was published in and notice again this concept of biodiversity and ecological integrity. So the method was published in May of 2019. After a fairly long development period, and there were several key principles that we wanted to capture with that indicator program. And the first of those is really this idea that we have knowns and unknowns with biodiversity, and that, if you like, much of our efforts, especially of a legislative variety or a legislatively required variety, has been very much at the tip of the iceberg of biodiversity. That is, those species we know about and we know to be threatened. So you consider that the most known of biodiversity, but then we've got known species that have been discovered and catalogued, but which have not been assessed for conservation status, or for which we have very little data about what, even the distribution of those species. And so it would be very difficult to assess them for conservation status. And then we've got the rest of the iceberg, which is all the things we don't know about at all. And so there was a intention and purpose to actually try and tackle those unknowns, both those known unknowns and those unknown unknowns, in the biodiversity iceberg, if you will. And of course, that does require that at some point we start modelling things, especially to cover and make assumptions and predictions, especially when it comes to those unknown unknowns. Another thing we wanted to do is make sure we sort of captured biodiversity, under the definition of biodiversity we're using is essentially the same as the Convention on Biological Diversity, and it's also the definition specifically given in the legislation, which is that, and part of that is talking about biodiversity at different hierarchical levels, so that we have genetic diversity being, and then species diversity and ecosystem diversity, and we do report on each of these levels in the first assessment. To some degree of success is how we do things. I should also say slightly outside of this hierarchy is phylogenetic diversity, and we also do that in the first assessment, and I will talk specifically that as well. Another principle that we wanted to include in the method is modelling on the RPSB framework and similar frameworks, which is to measure not only the state of biodiversity, but something of a feedback loop related to that. That is, pressures on biodiversity have an influence on the state. The state of biodiversity has an influence on what benefits we can derive from biodiversity. There are policy responses with respect to trying to specifically address the pressures, so that we try and capture this aspects of this feedback loop. And so we came up with a hierarchical arrangement of indicators, and so as I keep iterating, the idea of biodiversity and ecological integrity, so that's right at the top as two separate classes. So like I said, biodiversity basically follows the CBD definition, the variety of living animal and plant life, diversity within and between, and diversity of ecosystems, while ecological integrity is the diversity and quality of ecosystems. And so we've thought of this one along the lines of its capacity to, there's a couple of aspects to it. Its capacity to support biodiversity and its capacity, the capacity to adapt to change. Its integrity, if you will. So below that level, we have separate themes, expected survival of biodiversity. So this comes, another way of saying that is rate of loss of biodiversity, but we've tended to try and be positive rather than negative in our language. Then state of biodiversity, which is the one that most attempts to cover those unknowns. And then within ecological integrity, we have the quality of ecosystems, management of ecosystems, and the integrity of ecosystems. So, and we can break it down even further. So within themes, we have indicator families. So that's those. I should say that not all, I probably should have put little circles around or something about the ones that are in our first assessment. So ones that are in our first assessment are the expected survival of listed threatened species and ecological communities, the expected survival of all known and undiscovered species, state of biodiversity of all known species, habitat condition indicator family. Am I missing anything? I think that's the key ones. So The other thing we have, as I've said before, we have a high level of peer review, but we also have a high level of what we might call openness. So scientific rigor is important to us, and open science is important to us. So we have our technical method, and then we have our outlook report. So the method is pretty high level. It says this is a hierarchy, this is a justification for the hierarchy, etc. And with some detail about how those indicator families and specific indicators within those families might be developed, but the implementation reports are the actual implementation of those indicators. So it provides workflows, data sourcing, our justification for using particular data sources or models, and underlying those are data packages. So these are all freely available right now through our SEED portal, which stands for in Sharing Environmental something else starting with e-data portal. So that's yeah, so we can so you can access all of that. So what it means is certainly the intention was that given somebody using one of these technical implementation reports in the underlying data package, they could effectively replicate the indicator themselves. Thus, you know, being as open and as rigorous as we could with respect to that. We should also say, I should also say that we also have a companion report which came out because of the bushfires of 2019-2020. So there was a request from the Minister's office that we should do a quick response to in the style of our outlook report, which had already come out at that stage or was going to come out at that stage, to also factor in, also report on, you know, what we knew at the time about the impact of those bushfires. So getting to the outlook report, so we report 10 indicators in total across those indicator families that I mentioned before. And where we don't have working indicators at the moment, we can often throw case studies in there. So there's quite a lot of case studies in that report as well. What we're trying to do is report in terms of currency of that indicator. We tried to report as close as possible to the introduction of the BC Act, the Biodiversity Conservation Act. So that was August of 2017. So not every indicator is current to 2017, but yeah, as close as we could given the limitations of the data we had available. As I said before, every indicator family basically has a corresponding implementation report. That's how it works. So the outlook report glosses over a great deal of that technical detail. It's just for a member of the public to understand what the indicators are showing. It's actually quite minimalist in terms of interpretation. It's just literally stating the facts, if you will. But like I said, the implementation reports give a lot more detail. It says to be made available. Really should update that slide. So let's look at the results in that first report. And I'm going to do this a bit backwards. So in terms of the report, it starts with expected survival and then moves from there, you know, in the same order as the indicators are arranged in the hierarchy. But I'm going to actually start with ecological integrity and work my way forwards to expected survival. And the reason why is because some of these indicators are used to inform other indicators, and so it's easiest to start at this point, really, in terms of telling a story. So this is in essence what the report card, what we call a report card. So each indicator gets a report card, or well, at least each indicator family gets a report card saying what indicators are under this family and what their current status is. So for this we have ecological condition of terrestrial habitat and ecological carrying capacity of ecological habitat of terrestrial habitat, and we're showing a percentage score in this case of 44 versus 33%. You know, we just use a traffic light kind of arrangement, and we have an estimate of confidence. Unfortunately, in the outlook report, I think everything we've said is somewhat adequate. So, but that's just how it panned out. But we might refine that confidence indicator later. So. Obviously, it's not, like I said, not much detail here. We're saying This is where it is, and then of course, as we do more as we do more assessments over time, we should be able to track how these indicators move over time. So what's actually underlying this? Well, so we're starting with a spatial model of ecological condition across New South Wales. So using a whole variety of spatial products, which I definitely don't have time to go into as to how exactly it's done right now, but we're using a variety of remotely sensed data to feed into models feed into an overall model, which is to predict ecological condition, where effectively we're setting 100% to being the 1750 state, or the pre-industrial state, if you will. And so with this color scheme that you're looking at here, I don't know what to call that. That bluey green color is high values, and the orangey color is low values. So that's basically the color ramp. The resolution on this is 90 meters. And this is ecological carrying capacity, which is derived, as you can see, from that condition layer. And so what the difference is carrying capacity is condition while also factoring in connectivity, and condition is just plain condition. So that's the distinction, and you can see from that blow up there in the Brigalow belt area what that down weighting by connectivity does at a local scale between those two. So that means we can basically sort of partition that into three components at a statewide scale, or at any spatial unit scale smaller than that, you know, within reason, you know, given the 90 meter resolution that we have to work with. So overall in New South Wales, we can say that we've got 33% ecological carrying capacity, plus an additional 11%, which is effectively loss of carrying capacity due to loss of connectivity, and then the remainder, which is 56%, all the rest. And then, like I said before, we can then look at things like comparing national parks to other tenures and how it partitions across those components for those, which leads us to this histogram, which we did include in the Outlook report. So that was kind of brave of us, really. You'll note that we've got a log scale here. So we often refer to this graph as the whale, given its shape. And you know, you have to be a little bit careful because the log scale is a little deceptive in terms of how it, you know, in terms of its shape. But basically, what it's showing is that national parks does have high, as we would hope, has higher ecological condition on average than other tenures. However, there's quite a lot of land in national parks reserves that are getting quite relatively low scores for ecological carrying capacity. You know, and that's got to do, often it's got to do with connectivity, that we have a lot of national parks in New South Wales that are long and thin, or just plain small, or poorly connected to the rest of the network, that kind of thing. So you'll note that vertical bar. So that's just a somewhat arbitrary breakpoint between, you know, what we might call good condition, or sorry, places with relatively high habitat effectiveness versus places of relatively low habitat effectiveness. And then, you know, within that, you know, we can have statistics like this saying 62% of national parks in New South Wales are in that 62% of the area. I need to be rather specific about that. 62% of the area within New South Wales national parks is in that high habitat effectiveness. So, as I said, I'm moving from towards the back of the report towards the front of the report, and so we're moving on to another indicator, and so now we're in the state of biodiversity theme, I think it is, and then within that, persistence of ecosystems, vascular plants. So this is part of that state of biodiversity, a larger group, and here we're looking at ecosystem diversity. And we're making effectively an inference that compared to the original vascular plant ecosystem diversity in New South Wales, that about 80 to 84% is retained. So again, you know, we're just sticking with the basic statistics at the front in the report. And how we get there from this to this is via that ecological carrying capacity mapping that we previously did. So that in combination with an ecosystem classification for New South Wales based on a generalised dissimilarity model. So that's essentially it. You overlap those ecosystem types that we derive from that with ecological carrying capacity and make an inference based on species area curves, which is what we're looking at here, as to how much of that is retained. We're actually able to break it down in quite a lot of detail, and Michael Drelsma can definitely address that more specifically than I can. But essentially, we can fit separate estimates for each bioregion. So I haven't mentioned this before, but we tend to, as much as we can, report by IBRA bioregions. So that's generally how we do things with these indicators. We report at a national level, and where possible, we also report at a IBRA level, a bioregion level. So what that says is, what it does say, for example, is that certain IBRA regions are very much, approaching the edge of a cliff in terms of retaining biodiversity, given the current level of habitat effectiveness in those bioregions, which, as you can see, is largely the sheep and wheat belt sort of region across the western slopes of the Great Dividing Range, which of course has seen the most vegetation clearing. So it's not that surprising. Which is something I keep telling my superiors, none of these results are surprising. And then we get to getting now finally to the front of the report, the expected survival of listed threatened species. So here we're saying that without effective management, which is a very important corollary, that 50% of listed threatened species in New South Wales are likely to become extinct within 100 years, which certainly sounds alarming, and I will unpack what that means. And this is one of those ones where we were able to provide something of a historical trajectory. So here we're looking at 5-year intervals of the indicator. Excuse me. And we can also break it down into groups. So again, we can do this sort of partition thing where I can say how much of the diversity, and really important to remind you here that we're talking about threatened species. We're not talking about all species within some group. We're talking about threatened species. So we can look within that as what proportion we expect to survive, what proportion we expect to lose, and what proportion has already been lost. So that's also an important point to make, is that within that 50% are also known extinctions that have happened since 1750. So nevertheless, we're staring down the barrel of quite a lot of potential loss here in this indicator. And you can also see pretty clearly that most of our species lists, threatened species lists are basically either vascular plants or tetrapods of varieties, and things like invertebrates and even reptiles for that matter are quite poorly known. And then we get on to, now what I haven't said, I don't think I have a slide that specifies it, so I'll just say it now. So how did we come up with this magic number? So this is just based on the threat status of each of those species. So we can give each species a probability of survival within this group based on its current threat status. So that is just an inference from the IUCN criterion E, which is based on a quantitative analysis, that is a population viability analysis of probability of survival for a species of that category. So that's essentially where that inference is coming from. So the way to think about this, I think, is really just as a weighted sum, where critically endangered species get quite a low weight and vulnerable species get a much higher weight. That's basically how it works. So even if you don't believe the exact figure, it's just effectively a weighted sum, like a red list index indicator. In fact, it's very closely related to the red list index. And then we have expected survival of phylogenetic diversity. So for 3 groups, which I'll admit are all quite well-known groups, birds, frogs, and mammals, we generated a phylogenetic tree for those species in New South Wales. And then we were able to assign those probabilities of survival to the tips of those trees, and then, but also assign probabilities of survival to each of the deeper branches based on the probabilities of survival of each of the tips. So the probability of survival of a deeper branch in a tree is the probability that all the tips that descend from it, all the species that descend from it, also become extinct. That, well, let me say that another way. The probability of extinction of that deeper branch is a probability that all of its descendants become extinct. So obviously the probability of extinction declines quite rapidly as you pass down the tree, because it's very unlikely that all birds will become extinct in the next 100 years, that kind of thing. But again, we can partition it. So this looks a lot more encouraging, because in this case, we've included all species in New South Wales, regardless of whether they're threatened or not. And that's because of the way that that calculation is done. We can't ignore the non-threatened species. Otherwise we would be vastly overestimating threat. So to the rest of the tree, that is. So that's why we have this partition, but so it's effectively for two reasons. One is that we include all species, threatened and non-threatened, in these calculations, and secondly, because a lot of the tree is actually not at high threat, because it would take a lot of extinction to lose that much of the tree. But we can show you I can show an example where much of the tree has gone. So if we just look at the subtree of bandicoots in New South Wales, then less than half of it is essentially intact. So if we effectively, so let me start with this concept of phylogenetic diversity. So how we calculate that is it's the sum of branch lengths. So phylogenetic diversity given some set of species is the sum of the branch lengths that connect them together. And if we make the length of those branches equivalent to millions of years of evolution, so these branching points are, how long ago in the past those taxa split away from each other, then the sum of those branch lengths gives us a measure of phylogenetic diversity. And if we just, and we've been reporting it as a percentage, so just consider that, what proportion of that whole tree is secure or intact. So in this case, we're talking about, for bandicoots in New South Wales, less than 50% of the tree is secure. So which of these green branches? So we have two unthreatened, or at least not listed, species in New South Wales: northern brown bandicoot and long-nosed bandicoot. And we have one threatened species. I think it's endangered from memory, the southern brown bandicoot. So those branches are under threat. And then we have these black branches of those where those species have become extinct in New South Wales. So a great deal of bandicoot diversity is just gone, including phylogenetic diversity. However, on the right-hand side, we have what could be recovered in New South Wales under the best possible outcome. Because of those 4 extinct species in New South Wales, 3 have populations in other states. So they're all arid zone species. And so, and at least in a couple of cases, there is efforts to reintroduce them to New South Wales, admittedly, in predator exclusion, behind predator exclusion fences, but nevertheless, there is a potential to recover quite a lot of that tree. The exception is the pig-footed bandicoot. We don't have any of those anymore. And then I've got another indicator here, which is expected existence of listed threatened ecological communities. So this is again very similar to the expected survival of listed threatened species. So we have a bunch of ecological communities listed in New South Wales, and we can estimate a probability of survival. Didn't seem like the right word, so we went with existence, probably, or persistence might be another way of saying it, and just sum that up. And in this case, because no ecological community in New South Wales has shifted in status over that sort of time frame, it's just rock steady. So I should just say that these indicators are robust to growth in the list. So one thing we certainly didn't want to do is just simply have a count of how many species were threatened in New South Wales and track that over time, because that could be quite meaningless. That could just mean a process of discovery of how many species are threatened, as opposed to, a growth in the actual number of species threatened. So we formulated this indicator such that in this case, we're reporting worst case scenario. That is, we assume that a critically endangered species listed in 2006, for example, was critically endangered before then. So the only way you can get a change in the indicator over time is if species shift status from one category to another. And then finally, we've got this is an attempt again of getting at that unknown. So we did that before with the ecosystem diversity. We were getting at that unknown thing, and here we are again, this time at a species level. So and this is specifically for vascular plants. So and here we're reporting 3 indicators. Firstly, that 73, we have an expected survival indicator for the group as a whole of 73% in 100 years. That would be the low end. You would expect that to be the low end of the range rather than the high end of the range. How much of the extant area occupied for those species? You know, so the percentage of original habitat which is presently occupied, and the within species genetic diversity, which is pretty high at the 79 to 91%. So this is in compared to a 1750 baseline effectively again. So how on earth did we do that? So effectively, the key indicator here is extant area occupied. We infer the other two based on that. So what we're doing is we're inferring the area currently occupied by a set of representative species. So we haven't looked at every single species of vascular plant in New South Wales. We've looked at what we're calling a representative set, and they're representative in the sense of environmental diversity. So they occupy a maximally diverse set of environments is probably the best way to say that. So we did that again using a generalized dissimilarity model. So we were able to see the variety of environments occupied by vascular plant species in New South Wales, and we used an algorithm to select a set such that that diversity was maximized. And then we assessed each of those. And we assumed that the pattern we saw within that was representative of the group as a whole, because we're reporting it as a percentage, we can do that. So like I said, it's all based on this extant area occupied principle. So the smaller an area occupied, so again, this is just effectively based on IUCN Red List Criterion B, I think it is. So it's we give it a notional threat level based on the area that it occupies and the decline, the observable decline compared to original area occupied. So this is based on, this is an inference based on known occurrence records. There's no underlying species distribution model associated with each of those, at least not yet. So it's really just based on an inference baking, well, it's an estimate of the size of the range now, it's an estimate of the size of the range in the past, and we do that by overlapping it with the ecological carrying capacity a layer again. So just seeing how much of that original habitat has low effectiveness, if you will. And so based on that, we can say how much, so you can see what our notional categories are here, but they're equivalent to IUCN Red List categories. We just gave them different names. So that they wouldn't be assumed to be absolutely equivalent. And then based on that, we can assign a probability of survival based on IUCN Red List Criterion E. And we can also infer the loss of genetic diversity, and we do that by effectively the equivalent of a species area curve, except now we're looking at proportional genetic diversity versus proportional loss of range. So that and because and so we have both a lower and upper estimate of that based on what coefficient we assign to that species genetic area curve or genetic diversity area curve. Right now, that is parameterized by data from the Northern Hemisphere. So one of the things we definitely want to do moving forward is use more local data, preferably from New South Wales, but not absolutely necessarily, to parameterize that relationship between genetic diversity and area occupied. And so just to summarise, that's the one-page snapshot of the Biodiversity Outlook report, showing the key figures. So I have covered most of these already, so I won't spend more time on it, but we also have this additional figure over here of 99% of New South Wales is protected in reserves. We don't consider that an indicator as such, because it's just reporting on area, but we do include that as a case study in the Outlook report. All right. And like I said before, we did have this fire and environment summary as a companion to the Outlook report. And that is based off 3 of the indicators that we had previously re-reported. So as you can see here, that ecological carrying capacity in the fireground was reduced by 39% since 2013, and ecosystem persistence, which is inferred from that ecological carrying capacity, was reduced by 4% since 2013, because 2013 is our reporting date for those indicators, because of the currency of the underlying data is why that is. So, you know, making an inference based on, you know, what we can tell about the size and impact of the fireground effectively. So, yes, I don't think I need to say any more right now. And then we have things in development. So this is a couple of things. There's a bit more going on than this, but these are the 2 that are most likely to appear in the near future as publicly available reports. One on invasive species. So this is the exposure of native biodiversity to invasive species pressure and the impact of that pressure. It is of a subset of species that we were able to assess. We don't really know how representative that subset is, but that's what we did. And then we have a community appreciation of biodiversity. So based on some survey data that we had available, but moving forward, we want to use survey data that we collect specifically with this indicator, just looking at the level of appreciation and support for biodiversity conservation that we see in the New South Wales public. So if you want to know more, there is a specific website, but if you just Google that, you'll get there, or Bing it if you prefer. So like I said, my name's David Nipperess, and 2 of my colleagues are here sitting in, Michael Drosmer and Jamie Love, who worked on the the ecological carrying capacity and ecological condition and persistence of ecosystem indicators. So they'll be able to help me out answering questions with respect to those. Thank you.
Wow, David, woo! Applause from around our various virtual places. Thank you so much. That was really terrific, comprehensive, fascinating, really helpful. I'm sure we probably have some questions about this. I've got a couple in my own mind, but I'm going to have a look at the question thing, and Andy will probably read out these questions for you and see how we're tracking with these. So, and thanks, of course, not just to you, David, also Michael and Jamie. You acknowledge there's a whole brain's trust of you there. So fantastic. Thank you. Andy, how are we going for questions here?
We've got a couple in. Hopefully we'll get a few more trickling in now that David's finished his presentation. But the first one that came in was, in the method, and I'm assuming this is in terms of the multiple indicators you talked about, does the hierarchy enable a breakdown between terrestrial and riverine aquatic species / groups?
Yes, the answer is yes, but right now we're very much reporting in the terrestrial realm. There's certainly an intention to report in the aquatic. We do have a bit of an issue in that our brief, if you will, is to report on the outcomes of the Biodiversity Conservation Act, which in New South Wales is rather clumsily separated from the Fisheries Management Act. And so anything that's covered by the Fisheries Management Act is not under our brief, essentially. So what that means for certain species, for example, is that we have marine mammals that's under our report edge, and marine reptiles and birds, but not fish or aquatic invertebrates and things like that. So, but yes, we did we have done some work on developing marine versions of those indicators, but it's still in development mode, is the short answer.
Great, thank you, David. That's
Andy, can I add a supplementary question to that?
Of course you can.
So does that mean that even threatened aquatic fishes, for example, don't come under this, and is there interest from those responsible for the Fishery Act for having those included?
There's no reason why we can't do it. It's just a case of whether we want to try and. So certainly our brief was to report. It's stipulated under the Biodiversity Conservation Act. So we reported only on those listed threatened species. So I'm just talking about the expected survival indicators now. We only reported on expected survival for those listed under that act, but there's no reason why I can't chuck Fisheries Management Act in there as well. It's just a case of whether that's wanted, really. It's certainly wanted by the public. And to be fair, this State of Environment reporting does combine those lists, so in New South Wales, so we can do it. But yeah, our initial scoping was if it's BC Act, then we do it, and if it's not, we don't, but we can.
Thanks, David. Back to you, Andy.
No, great, thank you. Another question, this one's from Jody. How's this information been received and responded to by decision makers?
Oh, by decision makers. So it is. So we're starting to use it, and certainly there's an internal push from my superiors to we need to make sure that this has impact. This whole program has impact, and quite apart from anything else, to make sure it just keeps happening. And that will happen if it's seen to be useful. So I'm not sure if I can go into any detail, but because it's not public knowledge right now, it's not public data, I should say, or public. But yes, it's starting to be used in internal decision making. I can say that without going into any more detail. And yeah, so I know about that. In terms of external, I don't know what it's being used to, but we certainly had quite a lot of requests for data prior to the public release of the report. So it's certainly been, people are certainly looking at it and have been for a while.
And just to add to this, you can tell you've put in a lot of time and effort into trying to make these very simple metrics. Have you found that decision makers still look a bit bamboozled by what these indicators are trying to tell them, or is it quite clear for them?
Look, I think it's always going to happen. Yes, we have tried to make them straightforward, and I think I pretty much had to fight to make sure that phylogenetic diversity got in there. But and that's one of the harder ones to come across. I think in the case of spatial model, especially if you gloss over all of the underpinnings, you just say, this color good, this color bad, then, so it's fine, they get it. Although they may want to question how you came up, your assumptions about that, which is fair. Yes, yeah, moving beyond counts, there is a tendency to just want to make everything binary and count up how many of this versus how many of that there are. So pushing for more continuous variables is important to me. Sorry, what was the question again? I think I got a bit lost there.
No, you've answered what I was asking you. You've done very well to come across
Excellent.
that. I do have another question that's just come in from Ian. Can local area indicators be extracted from your reports or data? For example, Kosciuszko National Park.
Yes, the short answer is yes, especially for our very spatially explicit indicators. So I'm thinking mostly of ecological condition and ecological carrying capacity, very much so. So our limitation is the resolution, the spatial resolution of that data. So I wouldn't be reporting on anything at 90 meters or less spatial resolution, but certainly for a whole national park, absolutely.
Cool. And this one's from Anonymous. It's asking, is this method planning on being repeated on other representative data sets? So I'm assuming this might be to not just New South Wales, but other areas.
Yes, we certainly would like. Obviously, you know, what you don't want to do is impose your method on someone else unless you're quite certain that your method is the best. You know, so it's not just a case of making sure that everyone uses the Biodiversity Indicator Program, but we certainly want people to be aware of the program and what we did, and that's an important motivation for making it as open as possible. You know, the underlying science as open as possible. But certainly, yes, we have been talking to a whole bunch of different groups about what we've done and how they might be able to use it as well. So at a federal level, for example, you know, because of course they're working on a similar kind of thing themselves. So yes, we're certainly keen to let them know what we have and why we think it's good and why it might be better than what they're considering at the moment. We're certainly doing that.
Great, good to hear. There's a question from Caroline about the data you've collected or used in these indicators. Were they existing data sets, or did you conduct new research to support, I guess, these indicators?
So certainly when we designed the method, a key remit really was that we had to use what was available. We weren't about to go and collect a whole bunch of new data because there was no budget for that. The budget was for development of a method. So we had to say, well, what can we do with the data that are available across New South Wales, which is a big job in itself, just getting an understanding of what was available, because and so yes, as a consequence, very much took the modelling route. I mean, even that expected diversity stuff is basically a very simple mathematical model, like the simplest. I can say that because I did it. But yeah, so we had to work with existing data. Yeah, I can certainly think in my dreams, I can certainly think of a system that would be ideal, which would be effectively a systematic network of observation points across the state that we can use to inform our indicators in real time. That would be fantastic. But right now we're using the data we had available. So I guess part of this answer, which I will admit is rambling, is that the methods are somewhat robust to that, in the sense that if we were collecting our own data, we could use it within the current indicator framework.
Perfect. Thank you for that. This is around the use of the indicators. So, and I guess if there's goals or targets in mind, Jodie's asked, have acceptable levels for the parameters been set in advance, or will this allow these to be developed? It being possibly a slippery slope to adjust your targets as you go.
So we certainly didn't set targets in advance. We're just reporting on what the current state is. Well, you know, in comparison to a baseline. So if there's a target, it's like the baseline, which is either our starting point at 2013 or, you know, a sense of intactness relative to 1750. Having said that, that's not a target because that's not plausible, but we're reporting with respect to that. I don't think, I think in our case, we're not trying to set a target. We're just reporting on status and trend. That is a policy issue, setting a target, I think. And we can certainly inform that debate. We can inform that conversation. Although we could say what the implications of certain targets are. I should say that.
Fair enough. I better ask this one because it's from the ARI director, Kim Lowe. Kim, I'm going to ask you to ask this one, to be honest. Would you be able to unmute yourself?
Sure. Can you hear me now? Yeah.
Yep.
And thanks, David. My typing didn't help at all with Andrew, so he's done incredibly well. So I'm saying I really do think this is incredibly impressive and innovative. It really does seem to be streets ahead of other jurisdictions. And so I'm asking, has there been any questioning about the veracity or the like? Because it's so innovative, it may well attract this sort of questioning. Have you got any comments on that?
Yeah, look, it has been. I don't really want to go into specifics, but it has been. So like I said, we went through peer review both internally and externally, and that was for the method and for the individual implementation reports. So So there was that sort of, if you like, that scientific level of questioning going on. And then, so it went through that kind of ringer, and we came out the other side. There's also been, like internally, when it comes to trying to adapt policy, there's questions about, and they're really questions just about the assumptions. It's like, are you setting us up to fail? Is really what it comes down to. But at the end of the day, it's like I think this is the same answer I gave before, which is about targets. Is that we can set targets and we can talk about the implications of setting certain targets, but at the end of the day, that's a policy question, I think, and we're here to inform policy rather than make it. Yeah, but yeah, certainly policymakers want to be confident that we have a robust method. That's certainly true, and that's fair too. And I guess what I've got to say to that is, well, we've been through plenty of peer review and it's all open. So if anyone wants to know how we did it, it's not a mystery. And that's really important.
Thanks, David. I think it's an incredible breath of fresh air. So congratulations.
I've got a question here, which I'm very curious on the answer to. Is data from citizen science able to be used in these indicators? For example, from the Atlas of Living Australia or iNaturalist or other equivalents? Yes.
Currently not, at least not directly, but yes. And it would be good to see that more, yes. Certainly, again, I'm just going to speak to my indicators, which are the expected diversity ones in terms of the ones I worked on directly. So the next step we're trying to do there is look at those, there's this big caveat at the beginning of my indicator which says, without effective management, this might happen. So what would happen with effective management? Well, for that, we really need to collect data on populations to see how they're tracking in response to management, which would hopefully be effective. So in other words, I'm talking about the Saving Our Species program in New South Wales, which does rely for some projects on citizen science data. So there's a fairly straightforward way in which it can be integrated. But a lot of our indicators work from occurrence records, and yes, citizen science can play a role in that as well.
Great to hear, the response I wanted. Question from Ray. When you looked at the ability of ecosystems to support biodiversity since the 2019-2020 bushfires, was there any disproportionate effects on riverine or freshwater ecosystems compared to terrestrial ones? I think more broadly, I think she's asking, was there any disproportionate effects on any of the systems you looked at that you noticed?
I'm gonna hand this question over to Michael and Jamie, who did that work. They might have an insight or two.
Yeah, I wish I could answer that off the top of my head, but they're definitely we do have the ability within the model to make those distinctions, but we did do this rather quickly and focused on the overall biodiversity outcome rather than breaking it down into individual ecosystems. But you can well imagine that there was big impact on the most the places, the ecosystems within the fireground, and that included in this case rainforest. So it is terrestrial, using terrestrial vascular plants. So we don't get into the aquatic, obviously. But I could probably chase that up if you're interested.
Great. Yeah, if you can follow that up, Michael, we'll try to connect you with Ray's email details. Ray, would you just be able to email us at ARI and we'll connect you guys up. Another question around, I guess, the modelling and its use in predictions. David, would you be able to comment on the predictive capacity of this framework for use of land, incorporating land use change, climate change, and other projections? is there any chance of adaptive management angle with these indicators?
Short answer is yes, but there's plenty of devil there in the detail. I'm just thinking, again, I'll just respond to the expected survival indicators firstly. So we certainly didn't factor that in initially, those forward projections, but especially with things like range, estimates of range size and how much of that might be impacted by projected land use and climate change. That's certainly plausible, and I have been thinking about it, funnily enough, recently. So yes, I don't know if Michael or Jamie want to respond to this with respect to the carrying capacity and condition.
With regard to Jamie here, sorry, with regard to condition and carrying capacity, I guess yes, those two indicators will be responsive to land use and management changes, where with the clause of where that's picked up in underlying data, and the scale of those changes are typically going to be relatively small and insignificant compared with the overall summarised results. But yes, they will at the finer detail be responsive to that. And same with the persistence of biodiversity as well, because that is very much based off that ecological carrying capacity.
I should just say, because I've actually forgot to, was that we actually have two indicators which are about integrity under land use change and climate change in development. Well, they're in our method, and one of those was in development, although I didn't talk about it today.
Thank you so much, David. I think we're just about 2 o'clock, so I might throw it back to Fern for any final thoughts or questions. Thank you again for the audience for asking those great questions, and thank you, David, for the great responses you were able to provide.
Thank you.
And the entourage of handover questions.
Yeah, absolutely. Thank you so much to all of you. That was really terrific. And I should let you all know that we have quite a lot of questions still remaining. There's a lot of interest in this, a lot of appreciation for the work that you've done, a lot of curiosity. We might try and bundle some of them up into some common questions and maybe get some further feedback on you, because there's a lot of interest in this. But thank you so much for your time today. Thanks to everybody for joining us in the audience. Please fill out Andy's survey in the chat to help us gather more data and continue to bring seminars that you enjoy. And please join us in the next one as well. But thanks to all of you. Thanks, everybody. Enjoy the rest of your day. Thanks to Andy for tech. Thanks so much, David and team. We'll catch you next time. Bye.
Bye.